second day, what we're going to take a look at here is properties of exponents once more. So if we take a look at our warm-up here, we have to decide if these true or false. And again, the nice thing about exponents is we can always write this out. So we have 14 g's on top, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 5 on the bottom, 2, 3, 4, 5. So if we reduce all those out to 1, yep, we're left up with 9. So this is true. A to the 2 times a to the 5. So let's write it out. We got 2a's, and then we have 5a's. So is that a to the 10th? Well, no, that's only a to the 7th. And anything to the 0 power. Well, we learned yesterday that anything to the 0 power is 1, because a to the 11th over a to the 11th, that we subtract. So that's a to the 0, but we know this equals 1. So we're going to generalize what we did yesterday. So we did the product rule yesterday. Product rule, so if we have 12 nines and 3 nines, we add those. So that's really 15 nines. So our generalization is that we add them. Quotient rule. We said that there's 5 on top, 2 on the bottom. So this actually leaves x to the 3rd. So our generalizing, we subtract them. Our negative exponents. We said yesterday to get to negative exponents, we have to move the side that it's on. So this becomes p squared. So when it's on the bottom, it becomes a positive, a to the n in the numerator. And if it's a to the negative n, we have to move that to the bottom, 1 over a to the positive n. And then we said anything to the 0 power. So this was like our warm-up. If we had 672 to the 11th over 672 to the 11th, we know our rule is that we subtract them, which is 0, but we know that the same thing over the same thing is equal to 1. So our 0, so this should be a to the 0, equals 1. So now we're going to investigate a couple more properties here. So our next one that we're going to look at is the power rule. So if we expand this, x to the 3rd, we have 2x to the 3rds. So this is x, 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 and x, x, x. So if we add those, that's x, or count how many, we have x to the 6th. So x to the 10th 3 times, x to the 10th times x to the 10th times x to the 10th. So if I was to write this out, 10x's. So there's 10. The second one, here's 10 more. And then the third one, here's 10 more. So how many do we have? We really have 30. So some of you might see this pattern here. Well, 3 times 2, that gives us 6. 10 times 3, that gives us 30. So that pattern, I'd write it out. Well, I don't want to write those out 11 times. Well, that's actually 44. Z to the 7th 5 times. Whoops. If I wrote that out, I'd have 35 of them. So make our prediction, I'm predicting I multiply. So our rule here when there's parentheses is that we multiply. So if there's more than one base, let's see what happens. This would be x to the 3rd y times x to the 3rd y. So x's, well, there's 6 of them total, and then there's 2. Okay, so it looks like I just kind of distribute this here. Let's see if that works here. We have it 3 times, 2x to the 5th, y to the 4th, 2x to the 5th, y to the 4th, 2x to the 5th, y to the 4th. So 2 times 2 times 2, well, that's 8. We have 5, 10, 15, 4, 8, 12. So does that work? Do we just multiply there? So we'd have 2 to the 3rd, which is 8. Yeah, so that works. So I'm guessing we just distribute that. So this is 4 to the 5th, x, 12 times 5 is 60, times y to the 5th. So in general, we distribute that. So a to the n times b to the m times n. So let's look at a couple examples here. So if I was to distribute this, I'd have 14 squared, then x to the 10th, and we distribute it to the top and bottom, so 2 squared times x squared. So let's see, what is 14 times 14? So that is 196. Oops. X to the 10th over 4x squared. But we can simplify this. So 196 divided by 4 is 49. And then we know we subtract, so this would be x to the 8th. So if we take a look at this next one here. So first we distribute, so 5 to the 5th. This would be x to the 15th, y to the 5th, over 10 to the 5th, x to the 50th. Well, if I simplify that, 5 to the 5th, that's 3,125. And this is pretty big, so I would let you let's just leave it as 5 to the 5th if I said no calculator here. But this we could simplify just to x to the 10th. So we have 5 to the 5th, x to the 10th, y to the 5th, over 10 to the 5th. So this next one here, well, let's take a look at our numbers here. So we have a 2 and a 4, so 2 times 4 is 8. And if we take a look at our x's, we have an x and x to the 3rd, so x to the 4th. And then let's see, we have a y to the 5th and y to the 7th, so that would be y to the 12th. So what about this next one? Well, anything to the 0 power we know is 1, so that whole thing is just 1. And now let's look at this next one. Okay, well, I'm going to simplify this first. 24 divided by 6, well, that's 4. Well, I have some negative exponents, so I'm going to do some flipping. Y to the 5th stays. Y to the negative 3rd goes to the bottom. X to the negative 2 goes to the top. And y stays on the bottom. Excuse me, this needs to be y squared because I moved it to the top. So we have 4 x to the 7th over y to the 4th. Then we have to the negative 2. So if I distribute this, it becomes 4 to the negative 2, x to the negative 6th, y to the negative 2. Well, we know we don't want negative exponents, so everything moves to the bottom. So 4 squared, x to the 6th, y squared. And well, I know 4 squared is 16. So x to the 6th, y squared. This third one, so let's distribute. We have 3 to the negative 2. X to the negative 10, 4 to the negative 2. Well, we don't want our negative exponents, so 3 squared goes to the bottom, x to the 10th goes to the bottom, 4 squared on top, and we can multiply those out, so 16 over 9x to the 10th. 4 to the negative 3, well, let's see, that's negative 4 times negative 4 times negative 4, so that would be negative 64. And this last one, we have negative 7 squared. So negative 7 times 7. And that squared just goes with that. So we have negative 49. So let's take a look at our properties of exponents here. So what are some of these properties? So we have a couple examples here. So when there's parentheses, we multiply it out. So a to the m, b to the m. So this next one, a to the negative m, would be 1 over a to the m. A to the 0 is 1. And then we subtract. And then this last one, a to the m over b to the m.